Millions of people are driving and riding trains hundreds of feet beneath the ocean floor. While whales swim above and cargo ships pass overhead, these travelers move through engineering marvels that took decades to build and cost billions of dollars. These 12 incredible undersea tunnels will blow your mind. Number 1. Channel Tunnel, UK to France. The Channel Tunnel, known as the Channel, is the longest underwater tunnel in the world at 31 miles long. This massive project connects England and France, allowing people to travel between two countries in just 35 minutes. The tunnel sits 250 feet below the English Channel, making it one of the deepest underwater passages ever built. Over 15 million passengers use this tunnel every year. Building the tunnel took 6 years and cost over $15 billion. Workers had to dig through solid chalk rock while dealing with water constantly seeping in from above. The project used 11 massive tunnel boring machines, each weighing as much as 1,000 cars. These machines could dig through 500 feet of rock every single day. The tunnel actually consists of 3 separate tubes running side by side. 2 tubes carry high-speed trains in opposite directions, while the third serves as an emergency escape route. The trains inside reach speeds of 100 miles per hour, making the journey faster than most flights when you include airport waiting time. Special air pressure systems prevent your ears from popping during the ride. What makes this tunnel truly incredible is its security system. Over 400 cameras monitor every inch of the tunnel 24 hours a day. Motion sensors can detect if someone tries to walk through the tunnel illegally. The tunnel has its own police force and fire departments stationed at both ends, ready to respond to any emergency within minutes. Number 2. Seikan Tunnel, Japan. The Seikan Tunnel, connecting Japan's Honshu and Hokkaido Islands, is the world's longest undersea rail tunnel by overall length at 33.46 miles. This massive underground passage sits 790 feet below sea level, making it one of the deepest railway tunnels ever built. The tunnel was born from tragedy when a devastating typhoon in 1954 sank ferry boats in the Tsugaru Strait, killing over 1,400 people. Engineers decided to build a tunnel instead of a bridge because of the unpredictable weather conditions in the area. The project took nearly 50 years to complete, with construction lasting from 1971 until its opening in 1988. Up to 3,000 people worked on the tunnel at any one time, and 34 lives were lost during construction due to cave-ins, flooding, and other mishaps. Workers had to drill and blast through a seismically active area where tunnel boring machines couldn't be used. The tunnel includes 2 unique underground railway stations, Tapi Kaitei on Honshu Island and Yoshioka Kaitei on Hokkaido Island. These stations were the first railway stations ever built under the sea and serve as emergency escape points. The main tunnel stands 3 stories high and reaches 284 meters below sea level at its deepest point. Special pumping systems work continuously to remove water that seeps through the tunnel walls. Today, the Seikan Tunnel mainly handles freight trains, making it a crucial hub for transporting agricultural goods between Japan's main islands. The tunnel's construction required engineers to overcome one of the most challenging underwater environments in the world. It represents one of the most ambitious engineering feats of the 20th century. High-speed passenger trains also use the tunnel, drastically reducing travel time between the islands. Number 3. Marmaray Tunnel, Turkey. The Marmaray Tunnel in Istanbul, Turkey, is a 13.5-kilometer long undersea railway tunnel beneath the Bosphorus Strait, linking Europe with Asia. The tunnel represents the world's deepest undersea immersed tube tunnel, with its deepest point at 60 meters below sea level. This groundbreaking project opened to passenger traffic on October 29, 2013, marking the 90th anniversary of the Turkish Republic. The tunnel makes history as the first standard gauge rail connection between Europe and Asia. The Bosphorus crossing consists of an earthquake-proofed immersed tube assembled from 11 sections, with 8 sections measuring 135 meters long and weighing up to 18,000 tons each. Engineers had to design the tunnel to withstand activity from the nearby North Anatolian Fault, which lies about 10 miles away and caused a devastating 7.4 magnitude earthquake in 1999. The tunnel runs 65 meters deep underground, with a 1.3 kilometer immersed section under the Bosphorus Canal. Construction required cutting-edge fire-resistant concrete developed in Norway for maximum safety. The complete Marmaray project cost an estimated $4.5 billion, though it eventually cost almost twice that amount. The rail service can carry 75,000 people per hour in either direction, serving Istanbul's population of over 16 million people. About 2 million people cross the Bosphorus daily via just 2 bridges, so this tunnel provides crucial relief from severe traffic congestion. The tunnel ventilation system includes 30 double impeller fans with diameters over 8 feet. During construction, archaeologists uncovered the oldest evidence of settlement in Istanbul, with artifacts dating back to 6000 BCE. The project creates a modern iron silk road by allowing freight trains to travel between Europe and China. The tunnel includes 3 underground railway stations, Yenikapı, Sirkeci, and Üsküdar. Normal train traffic, including commuter, high-speed, and freight services, started running through the tunnel in March 2019. Number 4. Öresund Tunnel, Denmark, Sweden. The Öresund Tunnel forms part of the remarkable Öresund Link, a combined bridge tunnel system connecting Denmark and Sweden across the Öresund Strait. This tunnel is the world's largest immersed tunnel by volume, stretching 3.7 kilometers long and 40 meters wide. The complete Öresund fixed link spans 15.9 kilometers total, with the tunnel connecting the artificial island Paberholm to the Danish island of Amager. This engineering marvel opened to traffic on July 1st, 2000. The opening had a huge social and economic impact, with the number of daily commuters growing from 3,291 in 2000 to 18,000 in 2010. Construction by Sundelink contractors began in 1995 and was completed on August 14, 1999. The total cost of the fixed link, including motorway and rail connections on land, was calculated at 30.1 billion Danish kroner in 2000. The project received financial support from the Trans-European Transport Network. The tunnel was designed to work in harmony with nature rather than against it, including environmental protections for marine life in the Öresund Strait. The artificial island of Paberholm was constructed from material dredged from the seabed and has become a sanctuary for flora and fauna. Biologists have identified more than 500 different species of plants on the island, which serves as a breeding ground for birds and habitat for the rare green toad. Only scientists are allowed to inspect the natural parts of this remarkable island. The crossing connects 2 major metropolitan areas, Copenhagen, the capital of Denmark, and the Swedish city of Malmö, creating a trading region of 4.2 million people. A 1-hour ferry trip was replaced by a 10-minute high-speed rail journey. The tunnel carries a data cable that serves as one of the most important routes for internet transmission between Central Europe and both Sweden and Finland. This incredible project demonstrates how engineering can unite countries while protecting the environment. Number 5. Tokyo Bay Aqua Line, Japan. The Tokyo Bay Aqua Line is a 23.7-kilometer marvel that combines both a bridge and tunnel system, connecting Kawasaki in Kanagawa Prefecture to Kisarazu in Chiba Prefecture. With a 9.6-kilometer underwater tunnel section, it ranks as the 4th longest underwater tunnel in the world. The tunnel section reaches 60 meters below sea level at its deepest point. This incredible project was nicknamed the Apollo Project of Civil Engineering during its construction. Construction took 23 years of planning and 9 years of actual building, finally opening to traffic on December 18, 1997. Engineers used massive shield machines weighing 3,200 tons and measuring 14.14 meters in diameter to excavate the underwater tunnel. The project had to overcome challenging conditions, including soft seabed soil, wind, tides and potential earthquakes. Workers had to develop entirely new construction methods to complete this engineering challenge. The tunnel connects to an artificial island called Umihotaro, which means sea firefly in Japanese. This man-made island serves as a rest stop, with restaurants, shops, and amusement facilities, where the tunnel transitions to the bridge section. Above the tunnel stands the distinctive Kaze no 2, or Tower of Wind, which supplies air to the tunnel using a ventilation system powered by the bay's constant winds. The tower has become an iconic part of Tokyo Bay's landscape. Before the Aqua Line opened, the journey between Chiba and Kanagawa required a 100-kilometer drive around Tokyo Bay, but now takes just 15 minutes. The project cost 1.44 trillion yen, about 11.2 billion US dollars, to complete. The tunnel dramatically cut travel time from Tokyo and Kanagawa to southern Boso Peninsula leisure spots. Today, highway buses regularly use the tunnel to connect major stations like Tokyo, Yokohama, and Haneda Airport with cities across the bay. Number 6. Busan Jeoje Tunnel, South Korea. The Busan Jeoje fixed link includes a 3.2-kilometer immersed tunnel that became the world's deepest immersed roadway tunnel when it opened, reaching 48 meters below mean water level. This engineering marvel connects Busan, South Korea's biggest port city, to Jeoje Island, the heart of the country's shipbuilding industry and a major tourist destination. The tunnel opened on December 13, 2010, and shortens the traveling distance between Jeoje Island and Busan by about 60 kilometers. It represents Korea's first immersed tunnel and was the second longest concrete immersed tunnel in the world at the time. The tunnel is located in an exposed offshore environment, subjected to strong winds, large swell waves, and strong tidal currents, with significant wave heights up to 9 meters. The route replaced either a 210-minute journey by road or a 120-minute journey by ferry, cutting travel time down to just 40 minutes. The project was built under a public-private partnership, with most of the £1.2 billion project cost raised by GK Corporation. Construction took place in challenging ground conditions in an area prone to earthquakes and typhoons. The tunnel consists of 180-meter segments constructed in a dry dock in Anjeon, with the tunnel being made up of twin two-lane road galleries. The tunnel has exterior dimensions of 26.46 meters width and 9.97 meters height, with a total length of 3.6 kilometers and maximum depth of 48 meters below sea level. The complete fixed link is 8.2 kilometers long and includes 2 major cable-stayed bridges connecting various islands. Advanced positioning systems and weather forecasting technology were essential for the complex construction process. The project saves $300 million in costs related to traffic delays from the longer route and opens Jeoje Island to significant tourist-related development. At the time of construction, this was the deepest concrete immersed roadway tunnel in the world and represented one of the biggest engineering projects in Korea. The tunnel had to be founded on a thick layer of soft marine clay while being exposed to severe wave loadings from typhoons. Special foundation techniques were developed to handle the challenging soft marine clay conditions beneath the seafloor. Number 7. Hong Kong-Zhuhai-Macau Tunnel. The Hong Kong-Zhuhai-Macau Bridge includes a 6.7-kilometer immersed tube undersea tunnel as part of the world's longest sea crossing at 55 kilometers total length. The tunnel comprises a 22.9-kilometer sea viaduct and 6.7-kilometer subsea tunnel section of the 29.6-kilometer main bridge. To accommodate the passing of 300,000-ton vessels, the tunnel sits approximately 40 meters below the seabed. This massive project opened in October 2018 after nearly a decade of construction. The tunnel is designed to withstand earthquakes of up to 8.0 on the Richter scale and represents one of the world's longest and deepest immersed tunnels. The tunnel runs between 2 artificial islands, Blue Dolphin Island on the west and White Dolphin Island on the east. The artificial islands have a surface area of 625 meters by 160 meters and serve as transition points between the bridge and tunnel while providing space for tunnel service buildings. These islands also offer spectacular lookout points for travelers. The HZMB link required an investment of about 120 billion Chinese yuan, approximately 15 billion euros. Construction started at the end of 2010, with the tunnel opening to traffic in October 2018. The project creates a one-hour living circle in the Pearl River Delta region, dramatically boosting economic development in the Greater Bay Area. The tunnel uses a dual carriageway with 3 traffic lanes in each direction and operates 24 hours a day. Before the bridge tunnel opened, travelers between Hong Kong and Macau had to rely on ferries or lengthy road journeys around the Pearl River estuary. The complete system connects 3 major economic centers and is both the longest sea crossing and longest open sea fixed link in the world. Advanced safety features include state-of-the-art traffic management systems, advanced ventilation systems, and comprehensive road safety strategies. The tunnel represents a remarkable achievement in international cooperation between Hong Kong, Macau, and mainland China. Number 8. Ryfast Tunnel, Norway. The Ryfast Tunnel system in Norway holds the record as both the world's deepest and longest underwater tunnel road, reaching an incredible maximum depth of 292 meters below sea level. This engineering marvel connects Stavanger, Norway's 4th largest city, with the municipality of Strand on the other side of the fjord. The system consists of 2 dual-lane tunnels, with a combined length of 8.9 miles beneath the sea. These tunnels officially opened in December 2019, taking the depth record from Norway's own Eiksund Tunnel. The Ryfast system includes the Ryfylke Tunnel, running from Solbakk to the island of Hundvåg in Stavanger, and the Hundvåg Tunnel connecting Hundvåg to an underground highway interchange. Construction began in 2013 and took 6 years to complete, finishing in 2019. The tunnels feature a 7% gradient slope, which is the maximum allowed in tunnel construction. Automated processes were used throughout construction to streamline the building process and save time and money. Workers used carefully placed explosives to blast away underwater rock, then remove the material using conveyor belts. The construction required excavating more than 88 million cubic feet of rock from beneath the seafloor. Special conditions in the freezing, wet, and slippery subsea excavation site required working in the most efficient and safe way possible. Engineers had to deal with extreme water pressure and challenging geological conditions throughout the project. The cost to drive through these deepest tunnels varies depending on vehicle type and weight, with discounts available through AutoPass agreements. These tunnels have transformed transportation in the region, allowing people to travel between areas that were previously separated by water. The Ryfast system demonstrates Norway's world-leading expertise in subsea tunnel construction. Norway currently holds the top 4 spots on the list of the world's deepest subsea tunnels. Number 9. North Cape Tunnel, Norway. The North Cape Tunnel is one of Norway's longest and northernmost subsea road tunnels, named after the iconic North Cape on Megaroya Island. King Harald V of Norway inaugurated this remarkable tunnel on June 15, 1999. This tunnel connects the mainland to one of Europe's northernmost points, allowing year-round access to the famous North Cape Cliff. The project transformed tourism and daily life for residents of this remote Arctic region. The tunnel burrows deep beneath the frigid Arctic waters, where temperatures can drop to extreme lows year-round. Construction required special techniques to deal with permafrost and challenging Arctic conditions that would stop most projects. Workers had to use specialized equipment designed to function in sub-zero temperatures while maintaining safety standards. The tunnel provides a vital lifeline for communities that were previously cut off during harsh winter storms. Before the tunnel opened, residents and tourists had to rely on ferry services that were frequently canceled due to rough seas and ice conditions. The Arctic waters around Norway's northern coast are some of the most unpredictable in the world, with massive waves and ice flows that can appear without warning. During winter months, some communities could be completely isolated for weeks at a time. The tunnel eliminated this isolation and provided reliable transportation regardless of weather conditions. The North Cape Tunnel allows tourists to visit the northernmost point of mainland Europe throughout the year, dramatically boosting the local economy. The famous North Cape Cliff attracts hundreds of thousands of visitors annually who come to experience the midnight sun and northern lights. Local businesses can now operate year-round instead of being limited to summer months, when ferry service was more reliable. The tunnel represents Norway's commitment to connecting even its most remote communities through advanced engineering. Number 10. Bømlafjord Tunnel, Norway. The Bømlafjord Tunnel is a subsea road tunnel that stretches 7.82 kilometers long and reaches 260.4 meters below mean sea level. This impressive tunnel connects the island of Foino in Stord municipality to the mainland at Dalshovda in Sveio municipality in western Norway. The tunnel carries 3 lanes of European Road E39 and opened on December 27, 2000, as part of the Triangle Link project. When it opened, it was the longest subsea tunnel in Norway and the deepest point on the entire European road network. Construction started in 1997 using the drilling and blasting method, with 2 teams building simultaneously from each end. The tunnel runs through complex geology, including gneiss, phyllite, and greenstone, created during the Caledonian orogeny 500 million years ago. The project was budgeted at 496 million Norwegian kroner, but came in under budget at 487 million kroner. Engineers had to navigate varied rock formations and challenging underground conditions throughout the construction process. The tunnel is 11 meters wide with 3 lanes and serves as a crucial fixed link connecting Sunnhordland to Haugaland. 6 hours before the official opening, the bottom of the tunnel was used for a wedding ceremony, making it one of the most unique wedding venues ever. The tunnel company held special courses for people with tunnel phobias to help them overcome their fears, with 60 people participating. The project eliminated ferry services and provided reliable year-round transportation for the region. Plans for this tunnel arose in the 1980s as part of Norway's broader strategy to replace ferry connections with fixed links. The tunnel was the longest subsea tunnel in Norway until the opening of the Karmøy Tunnel. The Bømlafjord Tunnel reaches a maximum depth of 260 meters, making it the 4th deepest subsea tunnel in the world after other Norwegian tunnels. This engineering achievement represents Norway's expertise in building underwater transportation infrastructure. Number 11. George Massey Tunnel, Canada. The George Massey Tunnel in British Columbia is the only road tunnel below sea level in Canada, making its roadway the lowest road surface in the entire country. At its deepest point, the tunnel lies about 22 meters below the Fraser River, withstanding significant water pressure through its innovative underwater construction. Originally named the Deas Island Tunnel, it was opened in 1959 by Queen Elizabeth II and was considered an engineering marvel of its time. This groundbreaking project was renamed in 1967 to honor George Massey, a former politician who championed its construction. The 629-meter-long tunnel was the first rectangular reinforced concrete immersed traffic tunnel in North America, and only the 2nd of its kind in the world. 6 concrete segments, each measuring 344 feet long, 78 feet wide, and 24 feet high, were prefabricated in a dry dock before being floated into position. Each massive segment weighed 18,500 tons and contained 6,100 tons of steel, requiring precision timing during construction, as the base, walls, and roof were poured continuously without stopping. The project used innovative dewatering techniques and required removing 2.5 million cubic yards of dirt just to build the construction dry dock. The tunnel was unique for being only the 2nd in the world to be prefabricated on land and then sunk into place, showcasing remarkable engineering innovation. Instead of the typical circular design, engineers chose a rectangular shape for more efficient use of space and resources. In 1964, George Massey himself paid the final toll of $1, marking the end of tolls for this vital transportation link. The tunnel originally cost about $16.6 million to construct in the 1950s. An earthquake early warning system called Shake Alarm was installed in 2009, making it the first commercialized earthquake early warning system, protecting critical infrastructure in North America. The tunnel opened in 1959 as a vehicle-only crossing, but no longer meets the region's needs or modern seismic standards. Before the tunnel, travelers relied on the Delta Princess ferry, but the tunnel reduced crossing time from up to 2 hours to just minutes. A new 8-lane replacement tunnel is planned for completion in 2030, representing a $4.15 billion investment in Canada's transportation future. Number 12. Thimble Shoal Tunnel, USA. The Thimble Shoal Tunnel is part of the famous Chesapeake Bay Bridge Tunnel, a 17.6-mile engineering marvel that crosses the mouth of the Chesapeake Bay in Virginia. The tunnel has a portal-to-portal length of 5,738 feet and provides passage for ships through a 1,900-foot channel with minimum 50-foot depth. This remarkable structure opened in 1964, replacing ferries that had operated since the 1930s. The Chesapeake Bay Bridge Tunnel is considered one of the 7 engineering wonders of the modern world and is the longest bridge tunnel complex in the world. The United States Navy specifically requested the tunnel design because they objected to bridging the Thimble Shoals Channel, fearing a bridge collapse could cut Naval Station Norfolk off from the Atlantic Ocean. The Thimble Shoal Tunnel crosses the old channel of the James River, which the Navy relied upon for its warships to access the Atlantic Ocean. The tunnel structure consists of prefabricated composite structural steel and reinforced concrete tube sections, 37 feet in diameter and approximately 300 feet long. Construction required sinking these massive sections into a prepared trench and covering them with at least 10 feet of protective material. 4 artificial islands, each approximately 5.25 acres in size, anchor the tunnel at each end and required massive granite boulders weighing 2 to 4 tons each. The maximum roadway grade in the tunnel is 4%, with a roadway width of 24 feet plus a sidewalk and 13.5 feet of overhead clearance. The tunnel was constructed using precise timing during slack water to minimize underwater current forces during tube connections. Engineers had to overcome the challenge of connecting prefabricated sections underwater using innovative pin and slot systems. In 2013, construction began on a parallel tunnel to handle increasing traffic, with completion originally scheduled for 2024. The new 5,700-foot bored tunnel is being built using a massive tunnel boring machine nicknamed Chessie, which encountered delays when it discovered an anchor underwater. When complete, the new tunnel will carry 2 lanes of southbound traffic, while the existing tunnel handles northbound traffic. This engineering achievement saves motorists roughly 95 miles and 1.5 hours compared to other routes, transforming transportation along the Atlantic coast. The next time you cross a body of water by car or train, remember that you might be traveling through one of the most challenging environments on Earth. These 12 incredible undersea tunnels prove that human determination knows no limits. From Norway's record-breaking depths to Turkey's earthquake-resistant design, engineers continue pushing boundaries deeper and further than ever before, with even more ambitious projects planned for the coming decades. What seemed impossible just a century ago is now routine, and tomorrow's underwater tunnels will make today's marvels look like practice runs.